Okay, in this video we're going to talk about setting up an interval or radius of convergence, basically figuring out what would x have to be to make the series converge. Okay, the main thing we're going to use here is ratio test, and there are other ways to probably look at this, but I think ratio test works the best. So essentially, we set it up. We say, okay, x to the n plus 1 divided by n plus 1. And I could, again, divide, by the nth term. Let me just go straight to this. Okay. And remember, ratio test said once you do that, you take the limit as n approaches infinity, and we need it to be less than 1. Okay, that's ratio test, to make something converge. So we do a little algebra here. We say, well, x to the n plus 1 divided by x to the n, that's just x on top. Okay. Now, you'll notice that the limit statement is in terms of n. We treat x basically as a constant. I'm going to pull it out front. Okay, I'm just going to move it out here. So I'm going to have x multiplied by the limit as n approaches infinity of n over n plus 1, because that was all that was left. It's less than 1. Now we look at this limit statement and we say, well, what is the limit as n approaches infinity of n over n plus 1? Well, the limit is 1. I'm just going to put a giant 1 here, okay? The limit is 1. So what I have is x multiplied by 1, which is x, has to be less than 1. Now, because series could be alternating, what we really should do here is remember that we could be doing an absolute value. So really we should be looking at the fact that x could be less than 1 or greater than negative 1. And again, the reason I put that absolute value statement is the series could be alternating. Now this is really it, and you say, well, the interval then is from negative 1 to 1. The radius is just half of the interval. So the radius of convergence is 1. There's one last thing we need to check. And what that is that would we have to check the endpoints. Okay, here's what I mean by that. If we go back up here and I just rewrote the series with, let's start with the right endpoint. Let's say I made x equal to 1. So I had the series, I had 1 to the n over n. And what I have to say to myself is, that converge or diverge? Well, 1 to the n is 1, 1 over n, that's divergent. That's a divergent p-series. Well, then I check the other endpoint. The other endpoint was negative 1, so negative 1 to the n over n. Well, that's a conditionally converging alternating series. So what I have to do is I go back down here and I say, well, you know what? X has to be less than 1, but it could be equal to negative 1 and still converge. So this is the interval of convergence. And this is the thing that people forget most often, is once you've done the ratio test, that's not that hard, but once you've done that, you also need to go back and check the endpoints, because that piece that makes it alternating, that could help us converge. So we got to go back and remind ourselves of that. Okay, always check the endpoints. Again, the radius of convergence in this case is just 1. It's half the length of the interval. Okay, let's do another one. So we set this up, x to the n plus 1 over n plus 1 factorial. And again, instead of, I'm just going to go straight to this. And we're doing the limit as n approaches infinity. And remember, we need this to be less than 1 because we need it to converge. So let's do some algebra. This is going to cancel with this. This is going to cancel with this. Okay. Now, let's think about, all we have left is an x. I'm going to pull that out front like a constant. And the reason I do that is because the limit statement is only in terms of n. I don't need to evaluate that, the x piece. So now I've got x multiplied by the limit as n approaches infinity of, well, there was nothing left on top, so 1 over n plus 1, and that has to be less than 1. Well, I want you to look at this now. Let's look at the limit statement. What is the limit as n approaches infinity of 1 over n plus 1? It's 0. So x multiplied by 0 has to be less than 1. Well, x multiplied by 0 is 0. What that means is that the interval of convergence is all real numbers, and the radius then is infinite. Now let's just think about this for a minute. We've done enough with factorials that I think you know that if x is any number to the nth power, factorial is stronger than any exponential. So what this says is that I can plug in anything for x, and because the bottom is a factorial, it's still going to converge. Therefore, where in the first problem we said, oh, to get it to converge, x is really limited. It has to be greater than or equal to -1 and less than 1. Here, x is unlimited. X could be anything, and it will still converge. Okay, let's do a couple more examples. So we got 2x minus 5 to the nth over n squared. So again, let's set up our ratio test. Okay, let's do a little algebra. Let's take our stuff that doesn't have an n and bring it out front. Okay, let's focus on the limit statement. Now we've got n squared on top, and we'd have an n squared on the bottom. So what's inside there is 1. Okay? So 2x minus 5 multiplied by 1 has to be less than 1. And again, I know it feels kind of weird to suddenly add this this piece of this absolute value, but remember the reason we do that is because we could be talking about an alternating series. So finally we just end this by solving. So we add 5 to both sides. Divide by 2. Like that. Now, let's go back up and check the endpoints. So if I plug in 2, okay, first endpoint, let's start on the left side this time. So 2 times 2, okay, so just, again, I'm taking this left endpoint, I'm plugging it in. 2 times 2 minus 5 is -1. So I've got -1 raised to the n over n squared. Well, it's alternating and it's convergent, absolutely convergent. Okay, let's check the other endpoint. So let's plug in 3. 2 times 3 minus 5 is 1. 1 to the n is, of course, 1. I can write 1 to the n, but it's 1 over n squared is a convergent p-series. Both endpoints make the make the series converge. So we add the equal statement because 2 and 3 also make a convergent series. Okay? All right, let's do one more. So we set it up. X is 1. In this case, there's not a fraction, so we just do this. The limit as n approaches infinity, we need that to be less than 1. Do a little algebra. Okay, I got that x, so I can factor that. And of course, I do a little more algebra with this. What's that? Let me bring the x out front. So I've got x by the limit. All that was left was an n plus 1. Okay. So focus on this right here. As n goes to infinity, the limit of n plus 1 is infinity. So x multiplied by infinity needs to be less than 1. Well, that'll never happen. So there's no solution to this. And you think back, and again, think about taking something and multiplying it by a factorial. Factorials are huge. There's nothing I could multiply factorial by to get this to converge. So there is no interval or radius of convergence.